The following program is a Town of Colonie television production of the William K. Sanford Town Library.
All right, well, if you're following the book world and the movie world, you know that there's, I think there's 2 books and a movie about the women who worked at NASA doing math, and this book is a similar situation, only in the field of astronomy. And just like in the movie and the NASA thing, like they were called human computers. I mean, couldn't they just have been called a mathematician? But anyway, Heidi teaches in the Department of Physics, Applied Physics, and Astronomy. And I just found out about 10 minutes ago she was part of a team of many researchers, I think 20 or so, that won a Nobel Prize. So she's our first Nobel Prize winner here to speak at the Colonie Library. And if you go to her webpage, she does all kinds of research in astronomy. Part of it says here, my current research is primarily related to understanding the structure of our galaxy through using stars as tracers of the galactic halo and the disk. In both cases, I have been instrumental in elucidating their substructure. I hope that these studies will contribute to our understanding of how the galaxy formed. In addition, the stellar substructure in both the halo and in the disk can be used to determine where dark matter is located within the Milky Way galaxy. Does everybody have that? So anyway, so here's Heidi Newberg to tell us about the book by Dava, Sobel, The Glass Universe.
So, welcome. So what you've heard in my introduction is that I'm an astronomer and I'm an expert in, math and physics and astronomy and things like that. And I think probably my shortest subject in school was history, okay? And what I discovered about this book is it is a history book, but it is a history book about women, which I know a lot about, and about astronomers and women astronomers in particular. So it is right up my alley, but I'm hoping nobody's going to ask me about the names and the dates in the whole book. There's a lot of names and a lot of dates and a lot of details. But I think it's a really important history of a group of people that have not been recognized properly for their contributions. And and it's a group of people, a few of them are names that I knew, but there are a few of them that I read about in the book, and I, of course, know about the results of their work, but I didn't know their names. And the amazing amount of work that they did on that topic, I mean, they should have been winning Nobel Prizes. They should have been people that are talked about in the history books. And the few whose names I did know are usually, the reason that I know their names is not because they just showed up in the monographs and the books and the classes that I took. It's because I am part of Women in Astronomy news groups, and these names sort of came up through there as women in astronomy, not as astronomers who had made really important contributions to the field, things that sort of form the basis of work that's still going on today. So it was interesting to me to see where the knowledge came from, and what these people had actually done, and what parts they hadn't done, and what parts were done by other people. So the glass universe. Just to tell you what the title is, in the late 1800s, which is when this book covers the late 1800s and the early 1900s, the turn of the 20th century, astronomy was at a turning point in what astronomy was doing. in the early days of astronomy, astronomy was about looking up in the sky and figuring out where things were. Okay, you would look up, and as if what we call astrometry, that you were tracing the paths of the planets in the sky, and you were cataloging all of the objects, positions of all the objects in the sky, and trying to understand, solar system mechanics, or trying to understand, things that are out there. And, one of the things that's always amazed me when I think about it is that my great-grandmother, who was born just before the turn of the century, grew up most of her life not knowing that we lived in a galaxy, because nobody knew that galaxies existed. The level of what people understood about astronomy at that time compared to what we take for granted now is amazing. But astronomy was making a switch between cataloging and figuring out more and more accurate positions of things and their motions in the sky. And moving over to try to answer the question, what are these things? What is a star? What is a star made of? What powers a star? And that switch was going on about in the early 1900s from what we now consider to be astrometry, or figuring out positions in catalogs, and going over to trying to understand astrophysics, or what are these things physically. And having glass plates and new technology for taking photographs on glass plates changed astronomy from what a lot of people still think I do, which is to look through telescopes, which I don't do at all. You think of the lone astronomer up on a hilltop somewhere looking through a telescope, and what astronomers actually were doing they were actually in the 1800s looking through telescopes and writing down their observations in a notebook. But the glass plates then allowed you to take a photograph of the sky and then develop it. They usually develop it the next day or something. You develop these things, and then you can keep them forever, basically, and then you can refer to them, and you can go back to them, and you can make calculations of them, and you can catalog all of the objects in them. And so that, anytime you have a new technique or a new technology or a new detector for detecting the stuff that comes from the sky, you have a whole wave of new discoveries. And in fact, people are still using the glass plates that were generated in that Harvard Observatory in around 1900 today. They're still being used today. In fact, there was a very recent grant that they got, I think in 2005-ish, so about 10 years ago, they got a grant to digitize all of these so that you can get them on the web. And the reason is because, we look at where objects are now and how bright objects are now, but if you want to look at the history of where they were and what their brightness was in the past, you can go back to these photographic plates from 100 years ago or more than 100 years ago and track their motion in the sky or their brightness as a function of time by using these plates. And so people are still getting good information out of them even today. But this was a whole new thing to have a big building, and they built big buildings and they tried to protect it from fire and protect it from floods and protect it from things going bad, that it is still there at Harvard. That is the plate archive, where they have, glass plate was maybe this big, or some were smaller and some were bigger. Where they store all these glass plates in, kind of like a library. It's the same thing as a library. You keep them safe so that people can see them in the past. And so this is the story of the creation of that plate archive. But what you find out when you look at the story of how this huge plate archive was produced and how it was analyzed and how the results and the science came out of it, a lot of that work was done by women. I want to move over to talking about what they call it, Pickering's harem, right? So I've heard that before, Pickering's harem. And in science, if you want to get things done, and I do, I have this self, you need people to do it, right? What you need is a group of highly educated, very smart, hardworking people who are going to put them into a cause and come out with your scientific result. And the realities of science in every era are that we are completely limited by how much money we have to do all that. This has been it's the reality today. It was the reality 100 years ago, and throughout this book, there will be, there's all this talk about how it was never enough money, even at the best observatories, the biggest and most successful, and with the biggest donations and money coming in. There's never enough money for science. You can always use more. And so you also look for a group of people that you can get cheaply. So you have to be, hardworking, highly educated, motivated, interested in your topic, and cheap. Okay. And at the turn of the century, Edward Pickering figured out that he could tap into exactly what he needed by hiring women. And so they had all of these photographic plates being taken, and the photographic plates necessitated that there would be somebody who would take this plate and measure, with a ruler basically, the position of every object on the plate, and then compare every object on the plate with a spot of a size, so then catalog for every object on the plate how bright it was, and to analyze all this data. And instead of having 100 objects that you looked at by eye, or even 1,000, they were looking at tens of thousands or hundreds of thousands of objects. And so you couldn't do that all by yourself. And he, would find out that there were these women who didn't have nothing else to do and were dying they were really good at math and computing, and they're very careful, and he had no trouble finding lots of women who wanted to work with him. And originally, the women who worked in astronomy were the wives or the daughters or the sisters of people who were astronomers. And, if they're in your family, they're smart, and you can work with them. And so you kind of bring them in and say, could you do this for me? Could you do this for me? Could you do that for me? In fact, Pickering's wife was one of those. I mean, she wasn't an astronomer. She wasn't trained as an astronomer, but she was helping him with all of his observations. She was helping him. She was out there at the telescope, helping him with the observation, doing some calculations and doing all of this. And no, I'm sorry, it wasn't I think Pickering is not Pickering. It was Henry Draper's wife. Draper's wife is what I was talking about. Henry Draper's wife was doing all this for him. So Pickering, got the friends of the friends and came in and started working on it. Eventually, also at that time, they started having the women's colleges started putting out graduates. So he was actually be able to get college-educated women who had taken calculus and all kinds of other courses and had a mathematical underpinning to work for much less than he could get any men to work in the observatory. And so he started hiring these. Now, one thing that's interesting to me is that it was not just at Harvard, and this is something that's not in the book. I'm just adding a little bit of perspective to this, is that this was something that was going on not just at Harvard, but it was going on all over the country. I don't know about all the world, but at least in the U.S. it was happening everywhere. We have in our local region the Dudley Observatory. And the Dudley Observatory at that time also had women in the observatory. In fact, they hired more women than men at the Dudley Observatory, and at the Harvard Observatory. They had more women than men. And they would come in and they would do these computations, and they'd work on the plates, and they'd measure all these things. I'm told by people who were at GE Research and Development in those days, they had women computers there as well. I mean, if you needed a computation done, you would call down to wherever they did it in those days, call down to whatever, I need some help with the computing, and a woman would show up in your office and she would do your calculations for you. So this was, in fact, I think there were 80 women who worked for the Dudley Observatory in between like 1900 and 1940 or something like that, doing these kinds of calculations. And you try to understand who were these computers. At the Dudley Observatory, we have pictures of them. You can see a photograph of the women at the Dudley Observatory, and they have names because they got paychecks, and so their names were in the pay. But we actually know nothing at all about the lives of the Dudley women because no one paid, no one wrote it down, no one tracked it, no one cared. There's a little, but the women in general, they were educated, they were smart, they were not married, okay? Because in those days, if you got married, then you were supposed to be taking care of your family, and your husband was, supplying the money, and that's what you did. And so if they got married, they left. It was the same at the Harvard Observatory. If you got married, you left. And so these women had a choice. They could stay with these calculations or they could leave. Another interesting thing about it is that there was a big divide between women's work and men's work. Okay, so women calculated things, they measured things, they tabulated. Men took the observations. So you would never see, women in those days actually weren't even allowed to touch telescopes. They weren't allowed to be there for the observations. They didn't plan the observations. They didn't write the papers. Even if they did contribute to the papers, the person who ran the observatory was the author, and in most cases, they were mentioned in the acknowledgement. I acknowledge the computers, that helped me do this. In the same way that you would, you might not even acknowledge, the secretary or the draftsman or someone who helped you with this project. They were just, some of the people who just did some of the grunt work for you for your discovery. Okay, and so they were in a very special position. And I always, think about in my family who the women are, because, I had strong women in my family, going back a very long way. And what happens to women when they're smart and they're capable, but they're not allowed to do things, right? My mother and my mother-in-law went to college in the 1960s, right? And and both of them, when they left college, got married, and left where they were going to be with their families. My mother was accepted to medical school, and she didn't go to medical school, instead had a baby, right? And the world changed after that, and so both of them, when they got to be older, became got advanced degrees and became professional. My mother-in-law became a lawyer. My mother became a computer science professor. But in the early days for them, they were there for the switch. You couldn't be married and work to you could be married and work, and it was a switch that happened way later than we're talking about in here. There was the 1900s versus the 1970s maybe, where women were allowed to make that switch. My the women they were talking about here are kind of would have been my great-great-grandparents, somewhere around maybe my great-grandmother's age. My great-grandmother was an English teacher, because that's what women could do. They could teach, right? Women could teach. But they couldn't be scientists, and it was expected. Actually, my great-grandmother made a big row about this. She made a row because when she got married, she didn't stop teaching. And that was really, unless there was some reason that you lost your husband or something like that, where you had to support yourself and then make an exception. But when you got married, that was it. You were out of the workforce. there are a couple things about, I started thinking about the book, what that I think are important. One is I wanted to talk about a few of these computers at Harvard, and I think Harvard was a very special place where they actually went beyond being just computers. And I think that's what makes this book really shows a very important development in the history of astronomy, is because in this case, and it didn't happen at the Dudley Observatory, and as far as I know, it didn't happen at GER&D and didn't happen at other observatories, but in this particular observatory, the group of women that were working there and the group of people that they were working with, and in fact, Edward Pickering, allowed for a transition to happen. And so this is a story of a transition where between women being computers and not being allowed to get married, and women becoming full-fledged astronomers, and so it's a story of how that transition might happen. It's also, an important part of the book, I think, that for me, looking at it, is how funding happened. And in this story, everything in science kind of depends on getting the money in to be able to do things. And there were the observatory was funded by private donations, and private donations are often made by widows. All right, so there's a very large fraction of science funding where there's a man who's rich, or or maybe a family that's wealthy and has passed money on to a woman who does not have children or who doesn't have something to go, and they want to do something in their husband's name. And there's all kinds of different stories about how that happens. I mean, Russell Sage is a common local one. The Dudley Observatory was funded by a widow of Dudley when that started. And there's Catherine Wolfe Bruce, who was a wealthy heiress who was was not an astronomer, who just decided she wanted to fund astronomy, and Anna Palmer Draper, who was Henry Draper's wife, who was a wealthy woman and wanted to do something that would make her husband's name live forever, who helped fund all this. And there's also the family of Maria Mitchell, who made a big fund in her name and did a lot of funding of this. And it's interesting that a lot of the funding for all of this came from very powerful, accomplished women. And I think that maybe kind of shaped how this transition was able to happen, that the funders didn't see the computers as non-people. They could see themselves probably in the women who were working in the computing. And it's interesting because, there's something called the Bruce Medal, and there's something called the Draper Medal. These are things I've known about. I've heard of these because they're still given out today that came out of this time. And there's something called the Henry Draper Catalog, which I've known about forever because, it was an extremely important catalog of stars. In fact, star names are called Henry Draper number whatever. And so it's something that's lived on till today. And the reason that catalog was created was because the widow of Henry Draper, who had been working in that area of astronomy, funded it in his name, so that there would be something of him that would live forever. And, sort of the same with the Maria Mitchell Observatory. It was in her name, but it was done by her family so that her name would live forever. So that's interesting. So here are some women that are talked about in the book. Some of the these are big names of women in astronomy, early astronomy. Wilhelmina Patton Stevens Fleming. She was the first woman to hold an official title at the Harvard University, which was the curator of astronomical photographs. Okay, so this is a woman who, she actually had been married, she was widowed, and she had a son. And she was from Scotland and found herself in Cambridge, in Boston, with needs of support, and she became Edward Pickering's house servant. I mean, she was the one that his domestic help at home was Wilhelmina Fleming. And there's a apocryphal story. It's not in this book, and it's probably not even true. But people always said, you know, that this started because Pickering had been saying, well, you know, you're not doing a great job. My maid can do better than you, and he brought this woman in and did it. Now, I don't know if it's really true, but she really did work for him as a domestic help because she needed money, and when he realized that she was actually really good at you know, doing scientific work, he brought her into the observatory, and she became the head of the computing group. So this is a woman who came in during the day. She loved her work. She ran the plate stacks. She did science. She advised all the women who worked under her. She worked with all the women. She chose all the women. She supervised them all. I mean, she's basically, you know, the assistant head of laboratory for the whole observatory, running all of the operations. And had, for most of the time, no title, hardly any salary, and would go home at night and have to take care of her son and, you know, take care of her house and, you know, do all of her bills. I mean, she's a widow, and she had to do everything on her own. And she just kept going and going and going on this. She built a stellar classification scheme for the spectra of stars, you know, one of the first ones from that era. She discovered 10 novae, which is exploding star, and more than 300 variable stars. It was a big thing at the time. You know, was an extremely important figure in our early astronomy of that time period. And I had really not known anything about her before I read this book. I mean, she's really an important person. There is some discussion, and you know, I can see this in the records from the Dudley Observatory. It's in this book with the records of the Harvard Observatory. Women, so she was paid $1,500 a year, and a typical male, you know, contemporary at the observatory was paid $2,500 a year. So, you know, it was a lot less, and there was no way to you know, there's no rectification for that. You know, I think she had a good salary for a woman, and you know, that was what she was. That was her option. That's the only option. Annie Jump Cannon is much more famous. Annie Jump Cannon is a very well-known woman, probably the best-known female astronomer. She classified from these plates that were coming in from the observatories several 100,000 stars, and put out these volumes of the Henry Draper catalog. You know, as you can see, there's just volumes and volumes of stars and measurements of stars and measurement of all the spectral lines of stars, positions of stars, all this stuff. And she built on the classification system of Mrs. Fleming, and created the spectral sequence that we all use today of OBAFGKM. Now, you may have heard of this or not, of the spectral sequence. It's the temperature sequence of stars. And she created that, and we still use it today. And when Mina Fleming died, she took over as head of the computing group in the Harvard Observatory. She was a very well-known, got a lot of awards, got a lot of international prizes, was on international committees. And of course, if she'd travel and go internationally, she would be the only female at any of these things. And of course, never married, because if she had, she would have lost her career. Yeah. She was born in 1863 and died in 1941. I mean, the book is really about the period from about 1880-something to 1830, but that's, yeah. Henrietta Swan Leavitt is also someone who's a very famous female astronomer. She discovered thousands of variable stars on the plate. And what she's known for is that she was looking at these variable stars and looking at how bright they were as a function of time. And she realized in going through all of her measurements that she actually found a whole lot of variables in the Magellanic Clouds, which are dwarf galaxies that orbit the Milky Way. You can see them from the southern hemisphere. And she discovered that the brighter variable stars in this, nebula, she didn't really know nobody knew what these things were really, but the brightest stars in this nebula had the longest periods of variation. And so this period luminosity relationship of Cepheid variables is an extremely important result for astronomy, because it is the way that we were able to, in the 1990s, figure out the distance to clusters in the Virgo cluster of galaxies. That's the reason the Hubble telescope was built, was to look for Cepheid variables in nearby galaxies in order to figure out how far those galaxies were away, so that we could calibrate our distances to galaxies. So, I mean, but of course, she never had a title. She had salaries like women's salaries. She never was a professor. She, could be a computer at Harvard, and that was her only option. And if she got married, she would be kicked out. There's I wanted to talk about the Maria Mitchell Association a little bit. So Maria Mitchell is a famous woman astronomer who discovered a comet in 1847. Okay, she's not really part of this story, but her relatives got together and put money together to form the Maria Mitchell Association, which funded the Maria Mitchell Observatory on Nantucket, and wanted to do outreach with the local people and have a whole going concern. And so they had a fellowship for a woman astronomer to come to the Maria Mitchell Observatory and give local talks and keep the observatory running, and they would give a fellowship out every year to a woman to do this. I think Annie Jump Cannon might have had the first one, but it was another way to get money for women to do astronomy. And that was started about 1906. They had the visiting astronomer program. In 1915, they had this woman, Margaret Harwood, was like for the fourth year had won this fellowship and was doing great work with the Maria Mitchell Observatory, and the association really liked her, and they decided, and they were going to lose her to faculty at a women's college, and so they gave her a permanent position. So that fellowship went away, but when they did that, they gave Edward Pickering at Harvard, and of course it's women who run this association, right? They gave Edward Pickering at Harvard a fellowship for they gave him money to fund an Edward C. Pickering Astronomical Fellowship for women, so that a fellowship could continue to be given to encourage women to go into this astronomy. What's very funny is that in 1923, when Harlow Shapley took over as director of the observatory, one of the things that he wanted to do was start a graduate program. They didn't have a graduate program at Harvard. And so he needed money to fund a graduate student so he could admit a student into the program and have, you couldn't have a graduate student if you didn't have a fellowship to pay for him. The only fellowship that was available was the Edward C. Pickering Astronomical Fellowship for Women. And so he scoured the world for a woman astronomer, or someone that could be a graduate student in the program. And so the first PhD in astronomy at Harvard is a woman, because that's the only person they had money for to bring this in. Okay, and eventually they solve this problem by, someone else, gives them money that is for men for a fellowship, the Agassiz Fellowship, and that was in 1926. Took to 1926 for them to have a fellowship for men, and so they had at that time Helen Sawyer had the fellowship for women, and they brought in Frank Hogg, who had the fellowship for men, and guess what happened? They got married. Okay, and so this is the beginning. They're like, okay, well, I guess we're not going to kick her out because she's married, right? And so this is about the time when women now are allowed to get married and not leave. And they have strong people like Annie Jump Cannon is around there, and she's been working with women and is decorated all over the place. And so this is kind of the change. Okay, now women are allowed to get married and still keep working, but that was in the 1920s. And it was much later, I think, in other places. But about that same time, maybe a little bit later, there's I think the next, extremely important, astronomical result was from Cecilia Helena Payne. And she was one of these Harvard fellows getting a PhD in astronomy at Harvard. She was actually the first woman to earn the PhD at Harvard, and the first person to win a PhD to get a PhD in astronomy at all at Harvard, the first female professor at Harvard, and the first department chair in any department at Harvard. So this is a big deal, female astronomer. I actually didn't really know who she was before I read this book. But what she did for her thesis, she came from a very very strong university in Europe, and came over to the U.S. to take this fellowship and be their first PhD student at Harvard. And she was from a group in Europe that was working on looking at the spectra. You take all the light from an object on the Earth and you spread it out in wavelength, and you can make a relationship between the element and the spectrum. And so you see this relationship. Now, in astronomy, people have been spreading the light from stars out into these spectra for a long time, and they saw these lines. But no one had any idea what these lines mean. When Annie Jump Cannon was making her sequence, she was just seeing that, there were these lines. You could catalog stars by these lines. You could see that there were transitions from one type of line pattern to another type of line pattern, and that's how she ordered all of the spectra. Was by this one sort of merges into be this one, which kind of merges into be this one, and kind of merges into be that one. She made this whole spectral classification, but no one knew what this mean. In fact, in her day, what they thought was that the sequence OBAFGKM was not a temperature sequence. They thought it was an evolutionary system. You start out at O and eventually you become an M, or you start out at an M and eventually become an O. They didn't know what it means. And so she came from a background of knowing about looking at spectra of elements on Earth, and she went to an observatory where she had spectra from stars, and she was matching them up. Okay, so she's the first person. She has access to all this data, and she's the first person to figure out how you can get the temperature of a star from its spectrum, how you can get the elemental abundance of stars from a spectrum. This is stuff we're still trying to work out the details of today. How do you figure out the physical properties of stars from a spectrum? And she did it in the 1920s, which is why she was the first professor at Harvard. And it was a huge contribution. Now, one of the things that she discovered is, she was figuring out how much of each element there was in these spectra of stars. And she said, for most elements, you can see the ratio of how much, calcium there is to silicon and how much silicon there is to, sodium and all these things. All the ratios of all these things are about like they are on Earth. Except there's 1,000,000 times more hydrogen and I guess helium, 1,000,000 times more of that in the stars than there is on Earth. And that is the first time anyone ever had any idea that the composition of a star might not be the same as the composition of the Earth. Because you would think the sun must be about like the Earth, except it's somehow hotter for some reason, we don't know. But when she went to Princeton to present her results, the big name astronomer there said it's impossible. And so when she put the paper out, she said, but this result is impossible, And of course, years later, this same professor at Princeton, who's pounding his head on this for years and years, eventually wrote a paper saying, no, it actually is 1,000,000 times more, And she actually did eventually marry. She married a Russian who defector, this astronomer who defected to try to come to the U.S. because situation wasn't so great in his country. And so she actually helped get him out and bring him here. So what did I want to talk about? One thing I wanted to say is that, the women versus men in astronomy, what's women's work and what's men's work, and how does that kind of carry over even into today. And this is not in the book, but this is my take on things. Which I figured you're here to hear that. If you wanted to read the book, you could just read it. One thing that I've known for a long time, but I never had any reason to associate it with it, is that if you go to conferences in astronomy that are that talk about stars or the structure of the Milky Way, there are a lot of women there. There are as many women as men in conferences where you're talking about the nature of stars or the Milky Way or things like that. I got my start doing astronomy in extragalactic astronomy, where I was looking at supernovae. So anytime you're looking at supernovae, cosmology, galaxies, and you go to a conference, when I was a graduate student, a postdoc, anytime I don't know what it is now, but anytime you go to a conference on those subjects, it was 1 in 10. And I actually think, after reading this book, that this Pickering Observatory might be the reason. I mean, what they did was stars and galactic structure. What these women did was study the spectra of stars, and under Shapley, they were studying the extent of the Milky Way galaxy. I mean, at the time he was working on the Milky Way galaxy, of course, we didn't know we were in a galaxy, and he was trying to figure out the size of the universe, because the Milky Way galaxy was the universe, and try to figure out whether we were at the center of that universe, and of course we're not, and where our place in this is, and how, what it even is, and that's what was going on then. I mean, I work on the structure of the Milky Way galaxy, and I'm trying to figure out, the substructure of all the components of the Milky Way and how it actually got here, and we're still trying to work that out. But I think that by having this really strong cadre of women who then were professors at the women's colleges, and who were very important in all the variable star observing, which still goes on today at all the women's colleges that were training women at that time. There's a whole lot of advisors, that can come in and advise people and bring the next generation through. I mean, and that's really what it takes to make it in science, is to hook yourself up with someone who's going to, teach you the ropes and bring you through and recommend you for prizes and recommend you for positions and recommend you for giving talks. And without that, you don't get anywhere. And so, I actually think that's part of the history of astronomy, and that we still see the effects of even today. The other thing is, the history of women in astronomy is that women did painstaking work and figured out, relationships or catalogs and results. Men figured out what they mean and how they fit into everything else, and, a lot of times made a lot of mistakes that I don't think women are allowed to make, even today. That, William Pickering, who was Edward Pickering's brother, was the director of 2 observatories in his lifetime. But if you look at a description of what he did, you can't point to anything William Pickering did that, has any kind of the lasting consequences of these other women. And he was known to go off on observing trips and then not get the pictures. Sometimes he got them, sometimes he didn't get them. He was not always a success. He spent a lot of money, when there wasn't always money. His research that he's known for is canals on Mars, green vegetation and animals on Mars. So these are the kinds of things that he was publishing and putting out at the time, and he was the director of 2 different observatories. Okay, and so the women didn't get breaks like that, and you couldn't be wrong and still be. You had to discover the temperatures and compositions of stars to be a professor, and you weren't going to do it making these wild theories. And I actually, I think that's. It's hard even today to be wrong. I feel sometimes that I don't want to be wrong. Even if I'm teaching a class, I don't want to be wrong, because if I'm wrong, the students will think I was just there because they needed a woman. There's a more recent woman in astronomy named Vera Rubin, who I wanted to mention. Vera Rubin died last month. And Vera Rubin is someone who's come up every year as someone who all the women think ought to get a Nobel Prize and never does. And there's a strong history of women not getting Nobel Prizes. There are hardly any. Women don't get Nobel Prizes. And she's dead now, so she can't win a Nobel Prize. But she discovered, her discovery in the 1970s was that it was dark matter. So she discovered that the motions of stars going around the Milky Way was too fast. If there was not an extra unseen mass holding them to the Milky Way, those high speeds that they were going away would make the Milky Way stars fly out into space, and that doesn't happen. So there must be some mass holding it in, and so she published very convincingly that there is some unseen mass that is holding these stars in, because they have velocities that just keep that are not consistent with the amount of mass we see in stars. Now, if you read most papers that I've read on that refer to dark matter in the introduction, and if you look on Wikipedia, people point to Fritz Zwicky, who in the 1930s published a paper in an obscure journal in German that talked about something called Dunkelmatter in clusters of galaxies, that he figured that the velocities of stars going around the centers of velocity of galaxies going around the center of clusters was too high, and that there was some unseen force, maybe there's some kind of Dunkelmatter that holds them together. And what he was doing at that time, which was a really important result, is he was the first person to use the motions of objects going around another to try to figure out what the mass of it is, which is an important thing to have done. And in fact, he published that part of the result in a good astronomy journal the next year, and did not publish in that same paper this idea about there might be Dunkelmatter there. And why didn't he? probably because the errors on his measurement were so large that he didn't really know for sure. And then he didn't pursue that, and for the next, decades of his life, went off and made the Zwicky catalog of clusters of galaxies and was really working on that. And his paper on Dunkel matter got 0 citations. Until the 1980s, when Vera Rubin found dark matter in the galaxy, all of a sudden people dug up this obscure paper from the 1930s and gave him credit for the discovery of dark matter. So I'm very angry about this, and I point this out to astronomers everywhere I go. And I was at a conference a few years ago where I was talking to someone, and I told him that I thought Vera Rubin should get a Nobel Prize for that. And he said he didn't think so. And the reason he doesn't think so is because he was there at the conference where she was presenting this results, and when people were talking about the reason for the rotation curves of galaxies, the reasons for the measurements that she had been taking, she didn't really show signs that she had thought about the meaning of her results. And that she wasn't really jumping onto it has to be dark matter as the result, or it has to be some unseen kind of matter we don't understand about. And she didn't, in front of the lecture hall, show convincingly that she was, on top of this new result and its implications. And you can see the history of astronomy. Henrietta Leavitt didn't develop the reasons for her Cepheid period luminosity relationship. Annie Jump Cannon did not develop the reasons for her temperature sequence. That wasn't their job. In fact, finding the relationship or finding the spectral sequence wasn't their job either. They were just supposed to be measuring the stuff on the plates. They were supposed to be doing the grunt work was really what their job description was, and they were being allowed to go beyond that and actually do the science behind it. But anytime it was published or put in context or synthesized, that was not they weren't even in that discussion. And so, I kind of see this as, sort of a lesson to be learned in astronomy, that, women's work came from that. But if you really want to be given credit for the work that you do, you have to own it. And you have to be allowed to go out there and say, I think there are canals on Mars, and still keep your job. Because it's that synthesizing and trying to figure out where this goes in and selling your result that gets you recognition for having actually discovered it. And that's something that I just took away from having read this book. So you're getting kind of the book, but kind of my take on that era and what came out of it. What else did I want to talk about? There's one other topic, and that'll be my last, that I wanted to bring up. And we'll just open up to anything you want to, if you want to leave or you want to ask questions or have comments here. One thing that is sort of just exists in the book but at a low level that I think is kind of important to point out is the relationship between science and international relations, because I think there's an important connection there. Partly, trends in funding are political. They're not based on, we're doing great science, so science will get more funding. They're political. The funding for science is political, and it'll go down in a war, and science will get pulled out into the war effort. It'll go down when there's a recession. It'll go up for other reasons. It's a political thing. But the research that we do is international. I mean, we go to international conferences, we collaborate with people in other countries. I've run a collaboration with a group in China for a decade until recently. And when there's international political things going on, the flow of information, the ability to hold conferences in particular countries, the ability to attract people from other countries changes. For example, in this book I talked about wartime ciphers. They weren't allowed to transmit data from one country to another because usually they compressed it using a cipher, and you couldn't compress your data because there might be messages in there that you were getting out through these things. Also, in terms of, scientists are some of the first people that are allowed into countries when we're starting to normalize relationships, because as scientists, we don't really see national politics the same way as our politicians do, because we actually know people in other countries who are like us. When I go to China, I have dinner and I go out, talk to and collaborate with other astronomers in China. And I find out about not just the astronomy, but what their family is like and what life is like for them in China. And you really have personal connections with people in other countries that you get because you are doing the same work. And I think that's, you see that a little bit in this text, but I was just going to point out that that was there. Anyway, I've talked for a long time, and I'll stop and see if anyone has any comments or questions or anything they want to say.